This question assesses understanding of logistic regression and its appropriate business applications. Logistic regression is a statistical model used when the dependent variable is categorical, most commonly having two possible outcomes, binary classification, such as yes/no, success/failure, default/non-default, or renew/not renew. The key phrase in the question is anticipate a key business outcome. Students should determine whether the outcome is continuous, measured numerically, or categorical, classified into groups. Logistic regression estimates the probability that an event will occur rather than predicting an exact numerical value. It is widely used in finance, marketing, and customer analytics to predict behaviors such as customer retention, fraud detection, loan approval, and employee turnover. A. Predicting the continuous revenue for the next quarter. Incorrect. Revenue is a continuous variable, making linear regression more appropriate than logistic regression to be predicting whether a customer will renew their subscription. Correct. The outcome has two categories, renew or not renew. Logistic regression is specifically designed to estimate the probability of such binary outcomes. C. Forecasting the stock prices for the next year. Incorrect. Stock prices are continuous numerical values and require forecasting or regression models rather than logistic regression. D. Forecasting the number of new student subscribers in the coming month. Incorrect. The number of subscribers is a numerical count, not a binary classification problem. Correct answer, B. Logistic regression is most appropriate for predicting whether a customer will renew their subscription because it models the probability of one of two possible outcomes occurring. This question examines the type of dependent variable appropriate for logistic regression. Logistic regression is a statistical technique used when the outcome variable is categorical rather than continuous, most commonly with two possible outcomes. The key phrase is dependent variable, which refers to the variable being predicted. Examples include approve or reject a loan, fraud or non-fraud, customer renews or does not renew, and pass or fail. Logistic regression estimates the probability that an observation belongs to one category based on one or more independent variables. Students should distinguish logistic regression from linear regression, which predicts continuous numerical values such as sales, costs, or profits. Understanding the nature of the dependent variable is essential when selecting the appropriate statistical model for business analytics and financial decision-making. A. Binary correct. Logistic regression is primarily designed to predict a binary, two-category dependent variable, estimating the probability that an event will occur. B. Continuous, incorrect. Continuous variables, such as revenue or production cost, are typically modeled using linear regression, not logistic regression. C. Ratio, incorrect. Ratio data describes a measurement scale with a true 0 point but does not define the type of dependent variable required for logistic regression. D. Time series data, incorrect. Time series data consists of observations collected over time and usually requires forecasting models rather than logistic regression. Correct answer, A. Logistic regression is used to predict a binary dependent variable, making it ideal for classification problems where the outcome has two possible categories, such as yes/no, success/failure, or default/non-default. This question tests knowledge of forecasting and risk analysis techniques used in financial planning and decision-making. The company wants to evaluate the potential distribution of future operating profits while considering changes in multiple variables within its forecast. The key phrase is distribution of future operating profits based on changes in multiple variables. This indicates that management is interested not only in a single forecast but also in the range of possible outcomes and their probabilities under uncertainty. Such analysis requires repeatedly simulating different combinations of input variables, such as sales volume, costs, prices, and exchange rates, to estimate possible profit outcomes. This approach is widely used in capital budgeting, risk management, and strategic planning to quantify uncertainty and improve decision-making. A. What-if sensitivity analysis, incorrect. Sensitivity analysis typically changes one variable at a time to examine its impact on the outcome and does not generate a probability distribution of results. B. Time series regression, incorrect. Time series regression analyzes historical observations over time to identify trends and forecast future values but does not simulate multiple uncertain variables simultaneously. C. Multivariable regression, incorrect. Multiple regression estimates relationships between variables but is not designed to generate a distribution of possible future outcomes under uncertainty. D. Monte Carlo analysis, correct. Monte Carlo analysis uses random sampling and repeated simulations of multiple uncertain variables to estimate the probability distribution of future operating profits and assess risk. Correct answer, D. Monte Carlo analysis is the most appropriate technique because it models uncertainty by simulating thousands of possible scenarios, providing management with a distribution of potential future profits rather than a single estimate. This question evaluates understanding of data visualization techniques used to communicate analytical findings effectively. The analyst has collected 3 years of quarterly disease data and identified a recurring pattern. The number of cases rises significantly during the third and fourth quarters each year. The key objective is to determine the best way to present these findings so that seasonal patterns and comparisons across quarters can be easily understood by management. Students should remember that the choice of visualization depends on the type of data and the message to be conveyed. Since the data consists of discrete quarterly categories that need to be compared across multiple years, the visualization should clearly highlight differences in the number of cases between quarters and reveal recurring seasonal spikes. A. Table, showing the number of cases in each month for the last 3 years. Incorrect. Although a table provides detailed information, it is less effective than a graph for quickly identifying seasonal trends and comparing quarterly results to B. Pie chart, showing the number of cases in each quarter of the last 3 years. Incorrect. Pie charts are best for showing proportions of a whole at a single point in time, not for comparing values across multiple periods to C. Scatterplot chart, showing the change in the number of cases for each quarter of the last 3 years. Incorrect. Scatterplots are mainly used to illustrate relationships between two numerical variables rather than comparing categorical time periods. D. Bar graph, showing the number of cases in each quarter of the last 3 years. Correct. A bar graph clearly compares the number of cases across quarters and highlights the recurring increases in the third and fourth quarters. Correct answer, D. A bar graph is the most effective way to present quarterly disease cases because it makes seasonal patterns and year-to-year comparisons easy to visualize and interpret. This question tests understanding of the purpose of data visualization in business intelligence and management reporting. Data visualization refers to the use of charts, graphs, dashboards, and other visual tools to present information in a way that is easier to interpret than raw tables of numbers. The key phrase is primary goal, meaning students should identify the overall objective rather than a specific application of visualization. Effective visualizations help managers recognize trends, patterns, relationships, and anomalies quickly, allowing them to make better decisions. While charts may display rankings or operational variances, these are only specific uses of visualization. The fundamental purpose is to communicate information clearly and improve understanding, enabling users to gain insights from complex datasets more efficiently. A. Replace text and numbers with charts. Incorrect. Visualization complements text and numerical data rather than replacing them entirely. Reports often combine both visual and textual information. B. Illustrate operational variances. Incorrect. Showing variances is one application of visualization, but it is not its primary objective. C. Show rankings of data results. Incorrect. Rankings can be displayed visually, but they represent only one specific analytical purpose. D. Increase understanding of data. Correct. The main objective of data visualization is to make complex information easier to interpret, helping users identify trends, relationships, and key insights that support effective decision-making. Correct answer, D. The primary goal of visualization techniques is to increase understanding of data, transforming complex numerical information into meaningful visual insights that improve communication and managerial decision-making.